Hi, good afternoon, everyone. Thanks for coming for this talk. We're going to do a Ceph incident review. So on the agenda today, we're just going to go share a little bit of context, intro ourselves, share a little bit of context around how we at Neuralink are using Ceph, why we use Ceph, and then Odd will share a little bit about the journey that we've had with Ceph alongside with the incident and some of the aftermath and the learnings and action items that we have going forward. So quickly, by way of intro, my name is Eugene. I'm a systems engineer here at Neuralink, where I help build and maintain the systems and processes that are used by all of Neuralink to help create a brain interface, develop a robot, and all this other kind of stuff in between.
Yeah, and I guess I'm John. I am now ex-Neuralink as of the time between us submitting this talk and today. I was there for about 3 years, did everything from robotics to firmware to infrastructure, including maintaining Ceph. Now I just started a new company doing hardware testing, or hardware in the loop testing in the cloud for embedded products.
So by way of context, what do we do and what do we store in Ceph? Well, Ceph is primarily our main and only storage system for pretty much the entire company. We store things like medical studies, GLP data, so things that experiments that we run is all stored into our Ceph system. We built, as crazy as it might sound, our own LIMS data system as well, where LIMS, here, why don't you explain what LIMS does?
LIMS it stands for Laboratory Information Management System. It's, I guess I don't know what the exact analogy is, but like that's where we store all of our information about all of the animals or all of our devices or any measurements we take. And it's just a central place where you can find any bit of information about any study or any piece of equipment that we have.
Additionally, we store our training data and our models that we use for how to translate the signals that are from your brain into, say, a keyboard or a mouse, or in this case, a monkey playing Pong. And otherwise, all of our designs and architectures are also stored in Ceph as well. I figured this picture is a very good comprehensive depiction of everything that we store in Ceph. So, even when we do experiments and studies with our monkeys, we store all of those video recordings as well. The applications and the data that it generates is stored in data as well. All the designs that go into the chip, the robots, interfaces and stuff is all in Ceph. So this picture is like pretty comprehensive of why we use Ceph, and it really feeds a lot into our mission of helping to create this brain chip interface. Again, why do we use Ceph? Well,
I added the first bullet point here last minute. So actually one of the initial reasons why we chose to use Ceph was because we had a very high data rate, along with some data governance type concerns. But initially we were streaming at 10 gigabit per second line rate off of these neural implants. And this was something that was generating terabytes of data, and we just could never get a fat enough pipe up to AWS. So we decided to go with Ceph on-prem to begin with, but then it's kind of expanded into everything else.
So expanding into that, because we also want to have a little bit of AWS compatibility as well, the S3 API really fed a lot into our use of Ceph as well. Being able to talk it through one API was really useful. So as you could imagine, through all our use cases, we actually use Ceph in literally every single higher layer form of interface. We use Object Store via RGW. We use RBD to capture those video recordings from an app called NX Witness. And we also use it as a Samba share as well, so people can just drag and drop files around and share. Lastly, one of the things that we care a lot about is this concept of durability within our data as well. One of the things when you're building a medical device is that there are strict FDA requirements around uptime, availability, and durability of your data. And so with the way we architected it, the things that we have to do is actively kind of inject failures to prove out that what we assert about our data systems is true. And Ceph has done a really good job in terms of like the test cases that we've kind of conceived for asserting that we build reliable and maintain reliable systems, so that the data that is stored for preclinical studies right now, but later on probably clinical studies as well, will stand the test of time and can withstand potential failure modes. This is at a really high level. This is a really brief view of our architecture. It's been through a couple generations of iterations, right? By no means is this reference architecture, so don't look at this and go, hey, this is like, the way we should be deploying it. It's deployed across, the first 3 nodes are on storinators that, store up to 30 OSDs. The latter 3, if I remember correctly, are Dell servers that serve about 12 disks per. So it's fairly, like, heterogeneous type of hardware that we're using. And it's still currently running Octopus spread across RHEL and Ubuntu at the same time. So very, very heterogeneous across the point of time. As a sneak peek, as John walks through the incident, show of hands who's ever seen this at the same time within your Grafana dashboard and your Slack. It's a very unique case, also kind of alarming as well, and John's going to go into a little bit more of the details of it.
Yeah, I guess to kind of take us back here, Neuralink is still fairly new of a company. We were really scrappy for a very long time and are still very scrappy. I guess to kind of just get to the point of setting the scene of how we got to this failure mode, and not to say that we're particularly proud of this and how this all went down, but just like this was a very real instance of like how we were really trying to use the software and how we experienced this. I guess initially we got started with a 3-node cluster in 2018, deployed via Ceph Ansible. We benchmarked it, did all of our durability testing, whatnot, and this worked, and we stood it up, and basically at that point people just started using it as things happen in a startup. As in all good startups, we moved the servers via a car from our old site to our new site in 2020 when things got changed up during the pandemic. And then fast forwarding to present day, about a week before this incident, we started seeing our first set of failures from the initial set of hard drives that were racked in those initial 3 servers. So we had, I think it was like 10 or 12 drives in this first batch that were all, I think, matching uptime. So high probability for failure. About a day before this incident occurred, we saw another failure where we saw 2 OSDs go down. One came back online, the other did not, so we actually swapped out the drive and replaced it, and we started rebalancing. This is all fine and good at this point from what we understood. Along with this, there was a bunch of other confounding factors here, though, where like we had this cluster that was deployed in 2018 that we moved between sites. Our Ceph config bit rot because it wasn't something that we really maintained. It was something that had like kind of grown up over time to something that was used through a bunch of the company and had seen a lot of reliability, so we just hadn't really thought to really like operationalize a lot of this. Along with this, new member onboarding, bandwidth constraints on the team leading to like not actually causing failures all the way through. And at the end of the day, now we're operating in this degraded state where we have 1 OSD that is missing and is currently backfilling, which resulted in a couple of PGs that are now in a degraded active state. So, next morning, we all wake up to this Slack message. Our dashboard's green, but Ceph seems to be down. This is primarily through Rados GW users, because that's actually probably one of our highest use case. We acknowledge it, note that it's flapping between up and down. There's no one who's actually online with experience, and like at this point in time, we don't really have a super solid on-call rotation, just because like we didn't have that much of a high reliability concern for this service. It was business critical, but also like sort of best effort as things happen to be in startups. Something that we noticed that was very interesting was all of our RGW services were up, but HA proxy was claiming that the backends were down. So the instances were running but not serving any requests. In order to try remedying this, we'd seen similar problems with like out-of-memory conditions before, so we just decided to restart them all, but they continued falling into this down state. At this point, this is when the panic sets in, as it does in all people who are running software that is more complex than they understand. So we spend the next several hours trying to figure out any way to introspect the state of the system. Just enabling debug logs, tracing operations, seeing operations hang, just going through our like laundry list of things that could be causing this. Is our backfill that was currently running from the night before saturating our IO bandwidth or something? Did we do some misconfig where our op priority is inverted, where like recovery operations are taking priority over our client operations? Or like Eugene was saying, we have this weird mix of different things in the cluster where it wasn't the exact same patch version. And maybe there was a fix committed in the new version, and we just were like, maybe we should just try upgrading and going through commits and trying to just like read through the code and see what actually could be failing. Several hours into this, I think it was like 4 or 5, where we're all frantically trying to figure out what's going on. I decide to reread the Ceph status output, but really, really carefully this time. And I note the tiny like sliver of text where it's 4 PGs degraded rather than active plus degraded. And this was just something that I didn't even consider at this point, where it's just like, I don't know exactly what this terminology means. I flip back and forth between the docs trying to get a good grasp for what this actually meant. After some Googling and whatnot, I figured out that when you have a small enough bin size, Ceph will not do I/O on those PGs at all, including read I/O, until the recovery operation is completed. This is like something that you should know, and this is kind of why this is sort of embarrassing, but also like it's a really real scenario where through team churn and whatnot, I came into this without having a background in Ceph and kind of picked it up on the fly. And through this debugging process, we were able to actually narrow this down to, oh, we had lost a OSD the night before that was still backfilling. Now we had just lost a second one. These 2 hard drives had happened to coincidentally be the ones that were in this initial pool of disks. So they were storing a lot of the RGW data just because that's where the PGs were distributed, and we didn't have a large enough PG count to like actually spread it out over the many, many OSDs that we'd added in the meantime. At this point, notice the tunable, dropped it down with the understanding that this could lead to data loss with another disk failing. We had backups. It wasn't something that we were overly concerned with, and did the very advanced log monitoring technique of opening tmux with like 12 different panes and SSHing to every server and watching the logs until it recovered. I think it was like a 16-hour recovery or something. So it all worked, and the cluster went back into a healthy state. But sort of nerve-wracking to get to this point of like understanding the inner workings of this complex system that you're running without having a ton of expertise in that, or really like knowing how to look and like what specific little keyword you need to find what is actually wrong.
Now comes the fun part. With any exciting incident comes the incident review. And here's just some of the key highlights of what we learned, right? Every user has a certain perspective of what Ceph is. And as a result of that, when people say Ceph is down, when you see on your dashboard, hey, Ceph is doing quite okay, you kind of have to dig a little bit deeper into what they mean by Ceph being out. In this case, it's RGW, right? So it's kind of important to just kind of think about, the thoughts of how people are actually using Ceph, since it's so universal, and then kind of go from there. We discussed a number of things when it comes to even just, again, the heterogeneous nature of our cluster, where some things are just not completely configured properly. For example, in here we said we discovered that, config drift, and not all devices had smart on, and so Ceph couldn't automatically mark OSDs as out. So when you're in an in but down state, it's when things get really hairy really quickly. So what are we going to do? I think this is one of those things where, again, you kind of have to sit down once everybody's kind of calm again. You got to say, like, well, how do we get better from here, right? We're prioritizing backups to S3 for one. Like, the last thing that we ever want is, hey, look, if we have to run this exercise again where we degrade the PG min size from 5 to 4 and we risk data loss, well, at least the data is going to be somewhere. And so that's the first thing that we kicked off. For better or worse, we haven't actually automated backups up until now, and so we got that going. We're going to explore and deploy active-passive setups. One of the niceties that we have right now is that we have remote offices out in Austin as well, and so deploying a multi-region type of architecture is probably going to help with our reliability. Scan and replace aging smaller drives in the cluster. It's been around for several years. Some of these are 8 terabyte, 5,400 RPMs that have stood a lot of read and writes. Some of the newer ones are 18 terabyte, 7,200 RPMs, right? So we could get a little bit more density, but better performance as well, and of course, increase some capacity. What else? So we could upgrade and modernize our cluster. Again, I kind of mentioned that we were running Octopus. We're looking into deploying into Rook Ceph now that we stood up a Kubernetes cluster as well, and then get that into like the latest build and release. Failing forward faster. This kind of goes hand in hand with, you discover things as things fail. And so what better way than to try to like proactively inject failures and test it. This goes against with building a more reliable system, but also at the same time, it helps us because we have to actually do it for FDA regulations, that we do it periodically to continuously assert the reliability of our systems as well. Otherwise, in the industry name, it might be known as chaos engineering. And then finally, we are also growing our team. If any of the things that we talk about here, whether it's growing some of our software and systems, or otherwise maintaining some of these complex systems as well, is interesting to you, please reach out to me. I'm more than happy to discuss what we do as a whole and what our mission is, as well as some of the systems that we also use. And so with that, thank you, everybody. Just appreciate your time. I'm happy to take any questions. I'll start. Question is, how big is the current team? Between infra and IT spread across Austin, I suppose we have about 9 people, give or take right now. But we're all kind of generalists as a high level, right? So some come from a software background, some come from an IT background, some come from an infrastructure background, both on-prem and in the cloud as well. So by no means do any of us, I don't think any of us can actually say we're Ceph experts, for example, right? We just kind of are excited about technology and want to chip in where we can. Yeah. How fast is our network?
We have 10 gig links between all these nodes. I think the actual problem here was our PG number was undersized, so we actually were only able to restore at the read rate of these slow drives that we had initially put into the cluster, which was something that we quickly realized and fixed after this. Yeah, the question is which interfaces to Ceph are we using out of like CephFS, RGW, or RBD, and we use all of them for different needs. The question is, did we tune the object size or are we using defaults? and I honestly don't know because I did not set up this cluster. It's very possible that we have config that tuned object size because the two engineers who did set up the cluster are still at the company. Neither of us are them. But they did a bunch of benchmarking to actually ensure that we could hit the 10 gig line rate. That was uploading to through RGW at that point in time. So I don't actually know. Nice.
All right. Thank you, everyone.